Um, Dear students, in this slide, we are going to study about the normalization function. So we already know what is the first normalization. We have studied in the second assessment 2, okay, normalization 1. So in this slide, I will present about this, which is second normalization form, normal form. So second normal form, what are the two conditions here? Means it must satisfy the table must be in the one normal form. And second one, it should not have any functional dependency. Okay, so when we take this table, see this table attribute has multi-valued this has multi-valued attribute, and so multi-valued attribute, if it is there, means it is not in the form of first normal form. So we have to convert it into the first normal form. See, we have to convert this here. So this you have studied already how to convert that table into first normal form. The next one. So likewise, this is the representation of the first normal form. Okay, now we are going to go next one. We have to check whether the table has a partial dependency. Okay, so first we have to know here, we have to find out the we have to find out the candidate here. So these two in this table, the candidate key given is student ID and the course ID. And this is another one attribute is course fee. So these two candidate key attribute are called as the prime attribute. So here in the second normal form, we have to know what is prime and non-prime attribute. Okay, so prime attribute and non-prime attribute means prime attributes or that primary keys attribute, and the non-prime attribute other than attributes are called as the non-prime attributes. Okay, so these two things we have to find out. The next one, it checks for the partial dependency. What is partial dependency? See, there are two candidate key, but this attribute, the non-prime attribute, is only one. Before that, we have to see what is the functional dependency given. There are two functional dependency given, that is student ID and course ID. The course fee depends on student ID and course ID. Okay, that it is given like that. But again, it is given the course fees only depends on course ID. It no need student ID. The course fees, it depends only on the course ID. Based on the course ID, the fees are recognized. Okay, so this course fee, it only depends on course ID, not on the student ID. So this is called the partial dependency. This course fee is not fully depending on student ID and course ID. Partially, it depends only on course ID. So we call it as the partial dependency. How to eliminate this partial dependency? So what we are doing, we are taking this table, that is course ID. This has one table and another one course ID, and so this table can be decomposed into two tables. So one is the candidate key alone. Okay, the primary attributes alone taking in one table. That is student ID, course ID. Another one what? This course ID and course fees course. Course fees. This is another one table. So that we can rectify the redundancy also here. See here how many times it is represented. This one. Here you can reduce the redundancy also. For IoT only 750 and for artificial intelligence only 880. That is represented here. So redundancy also it can eliminate. So okay, this is the thing for eliminating partial dependency is second normal form. So third normal form, what is the condition? The table must be in the second normal form, as well as the table must not contain transitive dependency. If these two conditions are satisfied, then we can say the table is in the third normal form. Okay, so see here, table must be in second normal form. So when we check the dependency, the functional dependency is given. Employee ID is the primary attribute, and employee name and mobile numbers are the non-primary attribute. We can consider like that. So when we say about the employee name, it also depends on primary employee ID. Mobile number also depends on employee ID. So there is no partial dependency. So there is no partial dependency. So we can say this this table is in two normal form. So next we have to check for the transitive dependency. What is transitive dependency? If attribute, primary attribute, if A determines B and B determines C, C determines A. So if there is like this condition, that is non-primary attributes determines a non-primary attributes, or non-primary attribute depends on a non-prime attribute, then it is transitive dependency. So see here, this table, employee ID, all the project name, project ID, all are depending on employee ID. But when we take the project name, it is depending on project ID alone. So a non-prime attribute is depending on another non-prime attribute. Then we can call it as there is a transitive dependency. Okay, so transitive dependency. How this transitive dependency can be eliminated? See how this transitive dependency can be eliminated. We are decomposing this table, this main table, into two tables. That is employee ID, employee name, project ID as one table, and project ID and project name as another one table. Here also we can reduce the redundancy of data. See, we can reduce the redundant data and can form it in a simple database. So here the project ID, this is the foreign key which refers the primary key of another one table. So this is how we are eliminating the transitive dependency. Transitive dependency means a non-prime attribute, it's depending on another non-prime attribute. This is called as the transitive dependency. So this is one. The next one is the Boy's code normal form. So what is Boy's code normal form? It is it is also a third normal form, but it is an advance of the third normal form. Advance of third normal form. Here, first it must satisfy the first normal form, then it must satisfy the second normal form, that the table must not contain any partial dependency. Then third normal form it has to satisfy. That means no transitive dependency also. Again, when we come to the Boy's code normal form, the left-hand side of the left-hand side attributes, always it must be a candidate key or a super key. This one, LHS, it must be strictly a candidate key or a super key. So when we take this table is satisfied with one normal form, two normal form, three normal form. So we are coming for that is Boy's code normal form. When we take these two, these are the functional dependency given. That is the student, the teacher, it depends on the student and the subject. Okay. Teacher depends on student and the subject, but teacher depends on subject. That means what? This LHS, it does not represent the candidate or super key. So this is not in the form of Boy's code normal form. So here teacher is a non-prime attribute. It is not a candidate or super key. So how we are going to decompose this table into Boy's code normal form? Okay. This table we are decomposing into two tables, that is student and teacher, another one table, subject and teacher, that is teacher and subject, another one table. So here student and teacher acts as a foreign key, refers the primary key of other table, that is teacher, and subject, another one table. Thus we can achieve the Boy's code normal form. So now we can say student student determines teacher, it is a what? Primary key. Teacher determines student, subject. The teacher is a primary key. Now it's okay, no? So Boy's code normal form is achieved. The next is the 4NF. 4NF means what? The relation will be 4NF if it satisfies the Boy's code normal form. The table must be in Boy's code normal form, and but there should not be no multi-value dependency. Must not be there. What is multi-value dependency? This is the primary key, and this is the prime attribute. These are the non-prime attributes. So two non-prime attributes are depending on one primary key. So this we call it as multi-value dependency. This must be eliminated. So what you will do? You have to split this table into two. One is one table contains student ID and name. Another table contains student ID and course. So this is how we are achieving the 4NF. See, student ID and name, student ID and course. This is how we are achieving the 4NF. Then what is fifth normal form? 5NF. 5NF satisfies all the tables. See, just like 4NF only, all the tables are broken down into many tables as possible in order to avoid redundancy. So 5NF is also known as the project join normal form, PJ normal form. So this is the table given, and here student ID and mobile number, it takes us one table. Then mobile number hobby as one table. Then student ID hobby as another table. Likewise, as much of table we are decomposing from a main table in order to reduce the redundancy. So thus we can achieve the fifth normal form. So these are the things about the normalization. So watch this video. After watching this video, do the 9th exercise. Thank you.